So what I'm doing is I have two sessions opened up, so I'm going to see if this works out. I have my laptop and then I have the tablet open here. One of the things, hopefully you guys can see the same thing I see, which is this, where it's asking how many milliliters should the nurse administer per dose. Can you guys see that? You can just type in the chat box if you want to just say, yeah, I see it. I just want to make sure we're all seeing the same thing. Okay, thank you. All right, so in this question, and I thought I actually just wanted to see if this would work, and I'll work on the formatting and stuff like that. And what I can do is now I can kind of highlight, copy, and insert some of these questions, so that way I can kind of see what's going on, or at least be able to show you what I want you to see, I guess. So, all right, so the question says a nurse is preparing to administer morphine sulfate 2 milligrams IV bolus, and then what's available is 10 milligrams per milliliter. And the question is, how many milliliters should the nurse administer per dose? So when you're doing this type of equation, what I'm going to show you applies whether we're talking about this, which is morphine sulfate, which is some sort of a like a mixture, a liquid, so it's going to be an injectable, so it's going into their IV. So whether this is for an injectable, whether it's into the muscle, into the IV, subcutaneous, whatever the case may be, or if I'm trying to calculate how many capsules to administer to somebody, what I'm going to show you is the same procedure every single time. So in order to keep it simple for these types of problems, which are just your basic, your basic parenteral, I think that's how you pronounce that word, medication dosages, you take your order, which is the 2 milligrams, you divide it by what you have available, which is the 10 milligrams, times how many milliliters. Now, if it doesn't indicate how many milliliters, you assume 1, okay? That's actually what that means. You're actually not assuming. That's how many milliliters are there. If this said 2, then you would put 2 where I'm about to put milliliters. But whatever that milliliter amount is, or if you want, you could just leave it blank because it means the same thing, okay? But sometimes it's helpful to make sure you have a number here, okay? When you do this, 2 divided by 10 is 0.2 milliliters. So how many would you administer per dose? 0.2 milliliters. Now it's going into the IV, so it's probably going into some sort of like port in the IV. And so this has nothing to do with flow rate. And in your semester, you guys don't need to worry about flow rate questions just yet. This has everything to do with anything like that. Okay, so that's a great question. No, you don't have to write per dose. You just need to write the answer, okay? Nope, if it tells you per day, well, first of all, even if it told you per day, you wouldn't be able to answer that question because we don't know. They're just telling you how much to prepare. No, it would not be wrong to write per dose. It would just be extra information. All right. So let's try another one. So I'll leave that up while I pull up another one. Let's see here. I'm just skipping around. I downloaded a whole bunch of just practice ones. Oh, here's a good one. This is really gonna mess you guys up. I'm just kidding. This is not bad. It's just gonna look bad because you're gonna think that it's more than it is. So, all right, I'm gonna clear off this screen. Hold on a second. Someone just asked a question. Yeah, no. So I believe the question was if you're doing dimensional analysis wise. So if you took that equation we just did, and you did 2 milligrams times the 1 milliliter over 10 milligrams, multiply across the numerator and divide by the denominator, you're doing that. That's perfectly fine. Yep, that's the same thing. I always say, to keep it simple, multiply across the top, multiply across the bottom, and then do your division. Save your division for last. All right. All right, so this question, get it going here in just a second. Oops. Okay. Oh, it's there. All right. So I'm trying to fix the formatting here. So here's a heparin question. Heparin, notice a couple of important pieces of information. They're going to receive a certain amount subcutaneously. So that just tells you how to administer it. That's important for you as the nurse in practicality. But when it comes to math, the math part of this, we really don't care, because we just care about what do we need to do. So here the question is asking how many milliliters. So how many milliliters? Now notice it doesn't say per day or per dose. So you don't need to worry about that, because it just says to give them this amount daily. And so based off of the inference here, you're just going to give them this amount right now, okay? So that might just be once a day, and that's how that would be administered. If they wanted you to do it into divided doses, it would tell you into divided doses, okay? But for first semester, you don't really need to worry about that. You don't need to worry about that until you get into third semester, or when you do pediatric dosage calculations. That's when you start doing like some, you get a little fancy with the math. So you don't need to worry about that just yet. And don't worry, I'm here to help you. I've actually already got a ton of YouTube questions referring to that. So that's a very good question. So if you got, and I think, Taria, you just answered the question that Jared asked, you do not round a number less than 1. You go to the nearest 100th place. Remember, that's part of your rounding rules that you need to know. So you take, I'm going to show you the way that I did before. I'm going to take 3,800 units over 5,000 units. So all I'm doing is following the available or the ordered over half times 1 milliliter. And then I think you said you got 0.76 milliliters, and that would be your answer. Okay. Now, in some instances, it might tell you, like if you're on ATI and it tells you to round to the nearest 10th, then you would round to the nearest 10th. Okay. But for the drug calc, because it won't tell you that, like on the test itself, it's not going to tell you to round to the nearest 10th. You need to know to leave a number that is less than 1 to the 100th place. Okay. But if on an ATI or something like that, and it tells you round to the nearest 10th, then you do that. You round to the nearest 10th. And I've noticed on your ATI questions that they all say, for the most part, round to the nearest 10th. All right, let's try another one. And then someone asked if you have access to these questions. I don't have, these are not questions that I can administer out to you because they're part of the ATI. So what I'm doing is just getting a sampling of some of these ATI questions. Once I can go through and actually change some of the amounts and things like that, then that would be available to you, but I don't have these available to you. I don't think you need to worry about those types of questions just yet. Give me 1 second. Okay. All right, let me go back to the your test. All right, I'm gonna, oh yeah, I won't be able to do that. That's okay. All right, let's do a fluid replacement one. And I'm gonna see if I can change the numbers here. So give me 1 second. oh, let's just say for every 250, we're going to replace with 45, and then the actual out, let's just say, was 125. So I've kind of edited this a little bit from your practice test. So I changed a few factors, okay? So I said for every 250 milliliters of urine output, we're going to replace with 45 milliliters of water via the PEG tubing. If urine output for the last 3 hours is 125 milliliters, what would you replace the volume? Now, you may be looking at that and saying, well, they didn't void 250 milliliters, so maybe I wouldn't give them anything. But that would not be the correct way to tackle this problem. It just means you're going to give them less than 45 milliliters in the replacement volume. So if you recall before, I mentioned that a good strategy for these types of questions is to take the, I call it the theoretical or the expected output, so the 250 milliliters, and then to put that over the actual output. Oh, I'm sorry, I did that wrong. Ignore what I just said. I meant take the actual output, which is the 125 milliliters, over the expected output, which is the 250 milliliters, and then you're going to multiply by the replacement volume, which is 45 milliliters. If I can write. Okay. So 125 times 45 divided by 250, and I think I saw a number of you gave that, it would be half, would be the 22.5 milliliters. So again, this just comes down to practice. So if you're getting tripped up on where you're supposed to put things, just remember this is the actual out over like I said, I call it the theoretical, let's just say expected or initial out, and then this is the replacement volume. Okay, so it's helpful to know, because sometimes they might reword this question, and it might say, over the last 3 hours, your patient has voided out, 300 milliliters. What would the fluid replacement volume be if you're supposed to replace it with 45 milliliters for every 250 that are brought out? So you need to know that this is going to be is considered your expected or associated with your initial or your replacement, and then this is your replacement volume, and then this is the actual, how much they actually voided. Like I said, it just comes down to practice. That's why I gave you 2 on the practice test. Just gives you some things to kind of practice doing. So let me just see. Oh, I just cleared everything. Okay. All right. Let's try another one here. I'm going to see if I can copy some of these things. I don't know that I can copy the actual image that's there. Oh, okay. You know what? This was a problem for some people, and I'll explain why. So this is number 18 in the packet. I'm going to see if this copies. We're going to see. We're going to find out together. Oh, no, that's not going to copy out very well. All right. No. Well, you know what? Give me 1 second. I'm going to try this one more time because I think I can. Oh, here we go. Yay. Okay. Give me 1 second because I need to do some formatting. All right. I know you guys are not doing anything, so you don't need to worry about it. Okay. All right, so there was this question about the Pfizer pen. I was hoping that I could interject the table there, but I can't do that. I don't know if I can select it as an image. But we had our table looked like this. We had I'll write it in black here. We had milliliters diluent added, and then we had our units per milliliter. This, a nice little table here. And then what that looked like, I know you have it in front of you, but this just in case you're looking at this, you don't have it. So 18.2 milliliters, 8.2 milliliters, and then 3.2 milliliters. And then the subsequent concentrations were 250,000, 500,000, and then 1 million. So the question says to choose the strongest concentration, okay? So when you look at these, as I've already taught you before, we can just ignore that column because all that does is tell the pharmacy how much water to add to get to the concentrations listed here. This would be the weakest. This would be the medium strength. This is the strongest concentration. 1 million is more units per milliliter than 500,000, than 250,000, okay? So because of that, we know that that's the one we're going to use. Now, I gave you an alternative thing because in the key, you saw that it was 350,000. In the packet, I think it said 375,000. So I just changed the order here, and that's what I would do on your test. Is I would just change the actual order or the actual the amount in the order for this particular medication. So all you do for this question is you take the 475,000 units over the 1 million units times the 1 milliliter, and you'll get 0.475 milliliters. And then I'm seeing some of you have did the right thing and you rounded that to the nearest hundredth. Again, you're going to round on the test. On the test, your rule is to round to the nearest hundredth if it's a number less than 1, okay? On ATI, if it told you to round that number to the nearest tenth, then you just round that to 0.5. And I'm going to be honest with you, in a real life situation, the answer might just be exactly that. It might be 0.5. But under the, I always say the bubble of, dosage calculations, you try and get as specific a number as you can. So the best number is 0.475, but the answer based off of your rounding rules is 0.48 milliliters. If you got a number, I thought I saw someone plug in a number that was like infinitely like 0.00001. It looks like you did 1 divided by 1 million. So that's okay. No, I'm glad that we can rule that thing out. So yeah, you got to remember to multiply by the 475,000 units. And this is why when they tell you they want you to show your work, some of that is just to help you organize your content while you're going through this stuff. So that way, at least you have it ordered. So if you're not writing it like I am, if you're writing it, yep, absolutely, always double check. Plus, if you know you're going to be rounding to the nearest tenth or the nearest hundredth, there's no way you're going to get something that's, a micro, whatever, a micro unit. So, all right, let's see.
All right, when you're rounding, if it's above 1, then you round to the tens?
Correct. So let's just go over that real quick. So let's say I have like 33.45. Let's say I have 2.753. Let's say I have 0.125. let's say I have 75.515, just a bunch of different numbers. So the rule is, according to your CCAC blueprint, is if it's a number greater than 1, you're going to round to the 10th. If it's a number less than 1, you're going to round to the 100th. Now, that may not apply, and I'll give you an example of that. And well, let's just say I had 0.5, okay? So like this number right here, the 33.45, you would round that to 33.5, round to the nearest 10th. This number, 2.8. This number, because it's less than 1, 0.13. This number, because it's greater than 1, 75.5. And then this number, it's already where it needs to be. So you don't do anything with it. You don't need to add a leading 0. So you can just ignore doing that. You just need to have, just leave it like that, 0.5. If it's a tablet, they may want you to write it as 1/2. Just, that's the only other caveat. All right, are there any questions that you guys have had from the thing there? So your teacher said don't what? Oh, okay. Yeah, ultimately just depends on what they're referring to. So like sometimes for like, if they're talking about a tablet and you're fine with that, but you're absolutely right. The comment, make sure you ask your teacher what they want. Like I told you, like if you got an answer like this and it was 1.5 tablets, I would not, automatically deduct points if you did not write 1.5 tablets. To me, we're writing the same thing. So
Just real quick on the question with the table, the reason we went with the million is because it asked to use the strongest, right?
Correct.
So if it didn't ask for the strongest, we wouldn't just automatically assume that.
Right, but I'm gonna be honest with you, I don't know what you would assume then, because I don't know which one you would use, because you would get different answers if you used a different amount. So that was why I wrote into the practice test and into the real test to choose the strongest concentration. But I'm not 100% sure why or what would determine when you would use something versus something else.
Okay, but the question will be specific enough for us to know what to do.
As long as they use the same questions that I wrote up, or at least similar ones, then yes, it should be that. It should say to use the strongest.
Okay.
Yeah, good question. All right. Did anyone have any questions from the practice test or?
I think I like burn those out, so I was just looking for like different questions. I guess I don't know.
Okay, no, that's fine.
To memorize them.
No, that's fine. And like, there's something to be said. I'll tell you that a strategy that I used when I was in high school, I didn't have the greatest math teachers, so I felt like I had to kind of teach myself. Hold on one second. I just want to write something down here. Okay. And so one of the things I would do is I would just go through, find out what the answers were, and then I would repeat and practice the steps, because I knew that all that was really going to change when, at least when it comes to math and chemistry and in these types of questions, the only thing that's really going to change is the number. What's the order? What do you have available? And then putting those two numbers together to get to your answer. So there is a strategy to doing those. What I would say is you don't need to memorize the question, but if you're memorizing the steps, you're doing that right. You're learning from it. So so I changed, this was question this was question 25 on your practice test, and I changed the order, okay? So it's still what you have available. If I'm not mistaken, it's still 250 per 5 ml. Okay. So
I was about to say there's one number in there.
Okay. Yeah, so the available is 250 milligrams, and then it says per 5 ml. Okay. What is 5 ml also equivalent to?
1 teaspoon.
You got it. So if this question were to ask how many teaspoons would you administer, you could also solve that because you know that they're both the same. Okay. So 5 ml is 1 teaspoon, just keeping that in mind. So again, setting up a problem like this, well, first of all, it tells you, right? Tells you to calculate milliliters per dose, okay? If it wanted per day, then you would need to keep in mind that you're administering this 3 times a day, okay? But since we're not worried about per day, we're just worried about per dose, we just worry about right now. So I'm going to take my order. My order is the 120 milligrams, okay? So I'm going to take my order over what I have available, which is the 250 milligrams, times the 5 milliliters. Okay. And when you do that, somebody wrote 2.4 milliliters. So I'll go with that being the assumption. Was there any number, like was it a decimal answer? Like was there a 2.3 blah, 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 or was it exactly 2.4? Okay. 2.4. I like it when they end exactly as you want them to end, okay? So 2.4 milliliters is your answer. What would your answer be if this said how many milliliters would you administer per day? Good, yep. Times 3, and I think I saw it there, 7.2 milliliters, okay? So the way I looked at that, 24, 48, 72. I don't know if any else saw the 24 milliliters and thought 24 hours, and then so 3 days would be 72 hours. Anyways, that's the kind of craziness that goes on in my head. Okay. Now, what if this question had asked you how many teaspoons to administer? Well, the way I would set that up is because we know this is 5 milliliters per teaspoon, or that 5 milliliters equals 1 teaspoon, I would set this problem up exactly the same way. So 120 milligrams over the 250 milligrams, but instead of multiplying by 5 ml, I would multiply by the 1 teaspoon. What do you get when you do that? Okay. 0.48. Now, is that a rounded number or is that exact? Okay, good. Now, you can see that if you do any kind of cooking, you know that 0.48 teaspoons is very non-specific. In reality, how much would you probably administer? You'd probably administer half a teaspoon, okay? So like if I had a recipe and I was doing a conversion and it said to use 0.48 teaspoons of cumin, I'm going to use a half a teaspoon, okay? And then if you like cumin, you're just going to go ahead and round that up to a tablespoon because cumin's delicious. Okay. Let's see what else we got here. I hope you're finding this helpful. Oh, okay. I don't be surprised if I'm the one saying it wrong, guys. So I always say just because I sound like I'm speaking from a place of authority doesn't mean I got it right. I say quinoa right, okay? It's not quinoa. Okay. Okay. Here's a good one.
Or quinoa. I've heard some people say quinoa.
Quinoa, yeah. Okay. It's like, that's not it.
I have a a question. On the last problem, just for clarity, I had multiplied by 3 since it said TID, right?
Right. I
Okay.
just said if the question had asked you how many per day, then you would multiply by 3 because the order said to give it 3 times
3
per
times a
day.
day. Okay. All right. Thank you.
You're welcome.
But every time it says like TID per dose, you wouldn't multiply it, correct?
Right. If all you're concerned about is the dose, then you don't need to account for how many times it's being administered. You just care about right then, right there. And if you think about it, I put myself back in like the patient going to the pharmacy. So we're completely getting out of like the hospital or the doctor setting or even the nursing home or assisted living or whatever the case may be, wherever this would be different. You would be telling them to take half a teaspoon 3 times a day. So you focus on the half teaspoon that they take, with breakfast, with lunch, and with dinner. You just try and make it simple for them. You don't need to tell them, okay, you need to have 1.5 teaspoons throughout the day today. You're going to just confuse them. And so you're exactly right. You're going to take you only account for how many times per day if it asks you to account for how many times per day. But for the most part, these questions are going to ask you how many per dose. All right, so I'm going to change this question up a little bit. All right, so the order for this particular medication is cimetidine, 1.6 grams, POQID. And then the cimetidine is just the generic for Tagamet, and Tagamet is available in 400 milligram tablets. So in this question, you're asked to give how many tablets. Okay. Now, if you're quick on your feet and you're looking at this, you can sit there and just automatically give the answer and just be like, no, I got it. It's 4. Okay. Now, one of the things that's helpful if you're not seeing that right away, just remember that when you have an ordered and you have your available, they need to be in the same units. So you either need to convert milligrams to grams or grams to milligrams. I usually prefer, but you can decide whatever you want to do. I usually prefer to convert into the smaller unit, or I will usually only convert the order and not what's available. So 1.6 grams into milligrams is 1,600 milligrams. And all I did there was move the decimal 3 to the right. Another way to do that, just in case you need additional help, take the 1.6 grams. I don't want grams, I want milligrams. And that's how you get to 1,600 milligrams. Now that you have them in the same units, now you can take your 1,600 milligrams over your 400 milligrams and then multiply that by the 1 tablet, and you get 4 tablets. So I'm trying to change some of these things up. I told you that most of these questions are going to be exactly as they're written here. There might be different drug labels, there might be different Tubexes, and then I can guarantee the numbers will be different, okay? And because of that, you have an idea of what to expect on this test. There's not going to be any surprises outside of what you're seeing on this test, the practice test, okay? A couple little tidbits just to keep in mind. Make sure you mark your cups and mark the Tubex. Do not forget to mark those because they will mark you wrong. What they're testing you on when you test and mark the Tubex, they're testing to make sure that you know how that you can correctly identify where on the Tubex you would put your mark. Okay, so again, do not forget to mark the Tubex. I even wrote that in the answer key for this. Do not forget to mark the Tubex. Do not forget to mark the cup, whatever they tell you to mark, and do not forget to mark the syringe if that tells you to mark a syringe.
Number 17 in the practice test. Are you able to explain how to go about that?
Sure. So keep in mind the volume of diluent added, we just ignore that, right? So don't even consider that because it's just extra information that you do not need to worry about. But let me go ahead and get this cleared. Okay. And then I'm going to change the order here, and we're going to make it, let's just make it something bizarre. Okay. Yeah, I can go over number 10. Just remind me after I go through this one. All right. So for this question, it says that you have, well, I'll just write it out because I felt like that was helpful before. So you have a unison vial, and you have 2 vial sizes. Oh yeah, size. You have a 1.5 grams, and then you have a 3 grams. Now we've already been told to use the 3 gram vial, so we know that we're using this one. Okay. Then it tells you volume of diluent added. So volume diluent added. And then the last thing is the withdrawal volume. I'm just going to write with volume. Oh, look at it.
Would we just ignore the added volume since the withdrawal is the added included?
You got it. Yep, you just ignore that last, you ignore this whole column because that just tells you how much deionized, or how much, deionized water to add to the vial to get to the total withdrawal volume. And so you only care about the total. Okay, so this one's just a little bit different in regards to how we set this up versus the use the strongest concentration. So again, this just said to use the 3 gram vial. In reality, you're going to get the same answer regardless of which vial you use because they're the same equivalents. So it really doesn't matter, but the question told you to use the 3 gram vial. And so the way you would set this up is you'd take your 1,575 milligrams over the 3,000 milligrams. Remember, all I did was convert grams to milligrams, just my preference, and then multiply by the total volume, which is the 8 milliliters. Okay. And we do that. I think someone said, okay, so I'm seeing 4.7. Was that a number that was rounded, or is that an exact answer? Okay. What was the rest of the decimals if it was rounded? I apologize because you said yes. Oh, okay, thank you. Yeah, so 4.666666667. You're going to go ahead and round that to 4.7. Oh, now I'm hearing 4.2. So let's double check the calculator. I'll be the tiebreaker. Give me 1 second. Nope, I clicked on calendar. That is not the right thing. Calculator. I'm going to take my 1,575. I'm going to multiply by 8, and then I'm going to divide by the 3,000, and I will get 4.2 to the exact. So double check, double check, double check. 4.2. Now, if you got the if you got another number, sometimes the reason you get a number that's slightly different than what we're seeing here, a lot of times you'll get like something like 4.199999 is because you did multiplication, then division, and then you multiplied by 8. The problem with that is on a 10 key calculator, it doesn't account for your order of operations. And so sometimes that's why it creates a discrepancy. So double check why you got 4.7.
I use the actual question. I use 1,750 milligrams instead of your 1,575. So I'm sorry about that.
Oh, no, that's okay. Well, then you at least got it right for the original. So you're good. Okay. That's not a problem. No, I changed it just to like give you an idea of what it would look like if I changed the numbers. So, all right, well, good. Then we're all good. We're all on the same page. All right. Number 10 was the next one asked. When you say long way, do you mean dimensional analysis? Okay. Oh, you mean for the one I just did? Okay. So if I'm doing dimensional analysis, I'm going to take my order. Okay. What did I say? 1575. Okay. Times my 8 milliliters over my 3000 milligrams. And you'll get the same answer. 4.2 milliliters. Is that what you were looking for?
No, it's not.
Oh, okay.
So if you have like 1575 milligrams, and I know that you're gonna get 3000 milligrams, but let's say you didn't know that.
Okay.
You put the 3 grams where the 3000 milligrams are.
Okay.
So how would you go about that?
So the other way is if you left it at 3 grams, then you're going to have to convert the 1575 milligrams to grams. Okay. So you would divide by 1,000. Okay. And that will give you grams. And then the other way of looking at that is if I take that 1575 milligrams times, I don't want milligrams, I want grams. And then for every gram, there's 1,000 milligrams. That's why I get the divided by 1,000. And you'll have 1.575 grams. You do not want to round that, okay? You save all rounding to the very end. The only exception, and it doesn't really apply to you guys yet, is when you're doing like weight-based calculations, meaning that if you are converting a patient's weight in pounds to kilograms, you can go ahead and round to the nearest tenth for that. But for things like this, like your basic conversions, you do not do any kind of rounding until you're done with all the math for a particular problem, okay? So now that I have the 1.575 grams, I'm just gonna put that over the 3 grams times the 8 milliliters, and you'll get the same answer. Is that what you're looking for?
Absolutely, thank you.
You're welcome. Yeah, because sometimes I'm very like, I guess you can say loosey-goosey as far as what I'll do with these problems, because I know from experience that I'm not affecting the math is for where it's coming from. Some of you might be like, no, I don't want to change the 3 gram. I don't want to change that because that's what it says on the label, and I want to keep that there. And then that's why you have the alternative of converting either the milligrams to grams or grams to milligrams. You can do whatever you need to do. All right, number 10. Okay, let's see what number 10 says. Okay.
Can I ask a quick question, please?
Yeah.
I didn't see like any weight-based calculation. Doesn't mean we don't do it this semester or on a project test.
What kind of?
Any weight-based problem?
Correct. Yeah, you don't need to worry about those this semester. Correct.
Okay. Thank you.
You're welcome. I just want to try and, I'm going to change the, let me just see if I can get out of here and see that again. Let's see if I can do. All right, so I put up the patient ordered 65 milligrams Demerol. So this is question 10. It's available in the pre-filled syringe labeled below. And it says that it is 50 milligrams per milliliter. So what you have available is the 50 milligrams per milliliter. So again, I changed the number. So this is my order, okay? This is how I'm administering it. but that doesn't mean anything as far as the math is concerned. And then this is what we're looking for, how many milliliters to administer, okay? So when you do this calculation, you're going to take the 65 milligrams, and I think I already got an answer from somebody, over the 50 milligrams times the milliliters, again, that's 1, and you're going to get 1.3 milliliters. Then on your syringe, you're going to look to see where that is. So on the syringe, you can see where it says, so it says, I'm assuming that mepridine is the other name for Demerol. So it says 0.5, then you have 0.6, 0.7, 0.8, 0.9, and then 0.1. So each hash mark is a tenth of a milliliter. So you would just go, you would start with, you already know the half, so you go from the half, 0.5, 0.4, 0.3. So each hash mark is a 0.1 milliliter. So 0.1, 0.2, 0.3. And then you would mark on the Tubex like this at the 0.3. So let me just show you what that looks like. I'm going to draw it out. So I have 2, 3, 4, and then we had one here at 1/2, 5, 6, 7, 8, 9. Then I have another one here at 1, then 1, 2, 3, 4, another here at 1.5, and then I think, and it goes up to 2. So you just gotta make sure you count the ticks so that, and then you just put the appropriate number. Oh, so I'm sorry, I put this in the wrong place. So 1.123. I put my answer here. I hope that wasn't too confusing. Okay, so again, make sure you mark the Tubex. Don't forget to mark the Tubex, okay? That's commonly missed. I would say more so than any of the math. I get feedback that people just didn't mark their stuff correctly. So, all right, that was number 10. Any other questions from the practice test?
Hey, just real quick, I just wanted to make sure we're not doing any intermittent IV infusions problems.
If you mean like flow rate questions, then that would be correct. You don't have any flow rates. It's going to look exactly like this practice test.
Okay.
So if you don't see any questions like that, which I believe you're mentioning, like when you're talking about like intermittent, I think you're talking about like flow rate questions. I don't think that, at least from what I understand, you won't see those until next semester.
Okay. I did them in ATI. I thought we were assigned to them, but I guess we weren't. But I was just making sure.
Yeah, I mean, you need to know how to do those because you're gonna get hit hard with those next semester. Like, week 1, you take your drug calc test week 1, second semester, and there are flow rate questions on there. So they are getting you started on that. And to my knowledge, they haven't changed the blueprint for this test. But if you have any questions on any of the flow rate questions, I'd be happy to go over them.
Did you say week 1?
Yeah, for your second, third, and fourth semesters, you take your drug calc test week 1.
Wow, that's not good.
It's fine. Once you know to expect it, you just do it. It's just another. And then we do reviews like this in the beginning of the semester. I actually spend like 14 hours giving basically 2 1-hour sessions twice a day for second, third, and fourth semesters, and you'll be fine. Once you go through this.
I actually found them pretty easy actually because you just redo the problem just with a different number. So
right.
It sounds a lot harder than it actually was, but it's really not.
Nope, you just took the volume over the time and just reduced the numbers. It's probably all you had to do, right?
Yeah.
Okay, yep. You're doing it right then. Good job. I think the hard part with flow rates is thinking you need to do more. But I'm looking here to see if I have any, because I know I don't have any in your practice test, but I want to see if I have any my ATI practice set.
No, don't confuse us, like I'm just like.
What's that?
I said, oh no, don't confuse us, but I'm just playing.
Oh, okay. No, it's fine. If you want to just ignore what I'm about to do, that's perfectly fine. Let's just see. I just want to see if I have something here. Okay, this should be good. All right. This is a good one. And by good one, I mean you're going to hate it, but I'll show you just real briefly. And if you just want to ignore what I'm about to say as far as flow rate, that's perfectly fine. Don't feel like you need to pay attention here. But this will serve you some good in the not too distant distant future here. Okay, so the question here for flow rate says that you have a nurse caring for a client who has sepsis, right? So that means they have an infection in their bloodstream. Their prescription is for vancomycin, which is available in 1 gram or 1 gram and 250 milliliters of dextrose, 5% by weight. And it's to infuse over 2 hours via intermittent bolus. So this is exactly the question that I believe you were asking. So the nurse should set the IV pump to deliver how many milliliters per hour. Now the trick to this is the question tells you everything that's important. Okay, I don't care anything. I obviously I care that this person has sepsis and things like that in reality, but when it comes to math, it just, what are you looking for? It tells you specifically to look for milliliters per hour. Where do you have milliliters? Here. Where do you have hours? Here. So I just take my 250 milliliters over 2 hours and I reduce that to 125 milliliters per hour. That's flow rate, guys. It is for the most part that easy. There are certainly some things that are more difficult and more challenging, but that's what something like that looks like. So if you're getting these on the ADI, then that's it. Nope. Why would I change it to minutes? It didn't ask me to change it to minutes, right? So if it did, like if I was calculating like a drop rate, then I would. But
I was about to say I learned something with minutes before.
yeah. Yeah, and that's most likely you're doing drop rate. So drop rate is drops per minute, and that's just a whole different animal, a different question. It's similar because you still account for flow rate, but you never do something it doesn't ask you to do. So like if I were to calculate drops per minute, that's what it would ask me. It would say how much, what would you program or what would you set the pump to in order to deliver in drops per minute, and it would tell you that specifically. So you never have to guess like what they want you to do. Although sometimes it feels like you have to guess what you have to do, but that's not necessarily what the actual goal is. So, and I've looked at all these, a lot of these ATI questions and the questions that I put together, and I know that these questions are trying to it's just a matter of, can you read the information? Can you extract what you need from it and then answer the question? So like this one, I don't care about, I don't care about the 1 gram. I don't care about the dextrose 5% solution. All I care about is milliliters over hours. And that's how you solve these types of questions. So. All right. Are there any other questions that you guys have, practice test wise or otherwise?
I have a quick question about the test, but so for like 130's dosage calc, it'll be these questions from 110 plus the IV ones.
Oh, okay. Yeah. So there is, so you're talking about second semester, right?
Yeah.
Yeah. So when you get in the second semester, yeah, it'll predominantly be these types of questions plus some flow rate and some drop factor type questions. So the things that you're learning and practicing on ATI is very similar to what you're going to see next semester.
Okay.
Yeah, good question. All right. Well, if there are not any other questions, then, you know, I wish you the best of luck. And I hope I only hear from you that you passed. But if you need any kind of remediation, just let me know. I'm here for you guys. And like I said, I'll be available next week. Ultimately, it just depends on when you guys get your feedback. So, so if you need anything, you can email me, reach out to your instructor. If you also have any other last minute questions, just shoot me an email and I'll do my best to answer. And good luck, guys. You're welcome. You're welcome. You're welcome. Welcome.